Good day. We are the Group 2 and we are going to present the case study 2 about the Specialty Packaging Corporation. My name is Samantha Bukaw and my group mates are Guillermo Banoya, Samantha Ibe, and Magaling Janka. About the case. The goal of the team, which includes Julia Williams, SPC's Marketing Vice President and staff member, was to improve supply chain performance, as SPC had been unable to meet demand effectively over the previous several years. This often left SPC's customers scrambling to meet new client demands. The team's first task was to establish a collaborative forecast using data from both SPC and its customers. This forecast will serve as a basis for improving the firm's performance as managers could use this more accurate forecast for their production planning. Improved forecasts would allow SPC to improve delivery performance. Our problem statement would be, over the past 5 years, SPC had been unable to meet demand of clear plastic containers and black plastic containers. For our objectives, first is to improve SPC's supply chain performance, and second is to evaluate peak demand using forecasting techniques.
Specialty Packaging Corporation (SPC) turns polystyrene resin into recyclable or disposable containers for the food industry. Polystyrene is purchased as a commodity in the form of resin pellets. The resin is unloaded from bulk rail containers or overland trailers into storage silos. Making the food containers is a two-step process. First, resin is conveyed to an extruder, which converts it into a polystyrene sheet that is wound into rolls. The plastic comes in two forms, clear and black. The rolls are either used immediately to make a container or are put into storage. Second, the rolls are loaded onto thermoforming presses which form the sheet into containers and trim the containers from the sheet. Over the past 5 years, the plastic packaging business has grown steadily. Demand for containers made from clear plastic comes from grocery stores, bakeries, and restaurants. Caterers and grocery stores use the black plastic trays as packaging and serving trays. Demand for clear plastic containers peaks in the summer months, whereas demand for black plastic containers peaks in the fall. Capacity on the extruder is not sufficient to cover demand for sheets during the peak seasons. As a result, the plant is forced to build inventory of each type of sheet in anticipation of future demand. This figure displays historical quarterly demand for each of the two types of containers, clear and black. The team modified SPC sales data by accounting for lost sales to obtain true demand data. Without the customers involved in this team, SPC would never have known this information as the company did not keep track of lost orders. The first forecasting technique would be the moving average for period. We construct the template from the data given in the study, following the given quarterly historical demand for black plastic and clear plastic. First, following the 4 period starting from the first quarter of the second year, forecast is computed by taking the average of the given demand for black plastic and clear plastic. For the second quarter of the second year, forecast is computed by taking the average of the second quarter of the first year up to the first quarter of the second year, and then we drag the formula until the last quarter is taken. The next will be the forecast error. It is computed by taking the difference between forecast and actual sales. Next step would be the absolute error. It is computed by getting the absolute value of the forecast error. The next step would be computing the MSE. It is computed by taking the sum of square of forecast error divided by the period. Next would be the MAD. It is computed by taking the sum of absolute error divided by the period. And the last step would be the estimated value of standard deviation of forecast error. It is computed by multiplying MAD times 1.25. For the moving average technique, the estimated of standard deviation of forecast error of black plastic demand would be 2,699.40, while the clear plastic demand would have 4,198.13. We graph the actual and forecasted sales for the moving average. On the top graph, it is the demand for the black plastic, while on the bottom graph would be the graph of actual versus forecast of the clear plastic demand.
The second forecasting technique used is the simple exponential smoothing. The quickness of the forecast adjustment is determined by the smoothing constant alpha is equal to 0.05. This was set by the group. Following the same given data, for the first period, forecast is computed by taking the average of the actual sales of the black and the clear plastic demand. For the second period, forecast is computed using the formula smoothing constant multiplied by the previous actual sales plus 1 minus the smoothing constant multiplied by the previous forecast. Forecast error is the difference between the forecast and the actual sales. The absolute error is the absolute value of the computed forecast error. The MSE or the mean squared error is computed by taking the sum of the square of the forecast error divided by the period. The MAD or the mean absolute deviation is computed by taking the sum of the absolute error divided by the period. The formulas for the second forecast is used for the succeeding periods until the fourth period of 2019. The values of the demand forecast in the first quarter of 2020 is the same. The values of the demand forecast in the first quarter of the 2020 is the same until the fourth quarter of the 2022 for the black and the clear plastic demand. The estimated value of the standard deviation forecast is computed by multiplying the MAD with 1.25. The results show that the estimate of the standard deviation of the forecast error is 2,858.30 for the black plastic and 3,942.41 for the clear plastic. The graph shows the visual representation of the trend in the demand of the black and the clear plastic. The last technique used is the linear trend analysis. Following the same given data, trend is determined by linear regression using the data analysis regression of the Microsoft Excel. For black and clear plastic demand, the input Y range is the demand and the input X range is the corresponding period. Forecast is computed by multiplying the sum of the intercept and the X variable times the period. The formula was used until the fourth quarter of 2019. Forecast error is the difference between the forecast and the actual sales. The absolute error is the absolute value of the forecasted error. The mean squared error is computed by taking the sum of the square of the forecast error divided by the end of the period. Mean absolute deviation is computed by taking the sum of the absolute error divided by the period. These formulas are used until the fourth quarter of the 2019. The formula for the demand forecast was used until the fourth quarter of the year 2022. The estimate value of the standard deviation of forecast error is computed by multiplying the MAD with 1.25. The estimated value of the standard deviation of forecast error is shown on the green cells. That is for the corresponding years 2020, 2021, and 2022. The graph shows the visual representation of the trend in the demand of the black and the clear plastic. This concludes the calculation of the different forecasting techniques with the corresponding demands of the plastic. For the company Special Packaging Corporation, the methods recommended are the moving average for the plastic demand and the simple exponential smoothing for clear plastic demand. As shown in the summary, the corresponding techniques are selected because the results for these techniques show the lowest value for the estimate of standard deviation for the corresponding plastics. These forecasts would serve as the basis for improving the firm's performance, as managers could use this more forecasts for their production planning. Improved forecasts would allow SPC to improve delivery performance to meet unpredictable demand influenced by the season demand. Using information sharing and operation efficiency, will help the company to manage unpredictable demand.